Hi, this is Li Ming from UIUC, and I have two questions. First is that what's your thought on what is this fundamentally different from the backdoor attack? And the second one is that you are promoting the stealthy attack, but when we look at the camouflaged images, I feel like those added factor is still kind of visible. Yeah, that's my questions.
Thank you for the question. Okay, so for the first question regarding the backdoor attack, so the backdoor attack is basically you add a trigger, right? And then you assign this trigger to a specific label. And then whenever the model sees this trigger, then it just picks this label, right? So this can be classified as some classification task, right? However, in the model hijacking attack, there is no triggers, right? There is a completely different task which you are trying to do. So I would say that we can consider the model hijacking attack is like a more abstract way, where basically the backdoor attack is just one example of it, right? But then there can be different tasks that you can implement. And regarding the second one, I totally buy the argument that there is artifacts in the images and we are trying to make the attack look better, right? But then it's still more stealthy as if you consider the original images of the other task, right? For example, when you see the camouflage C-4 versus an MNIST, I would say the camouflage C-4, it's still more stealthy than an MNIST image.
I see. Thank you. Thank you for the answer. Great talk.
Thank you.
Hi. So I was wondering what the limitations are in terms of what you can hijack, because it seems like, for example, in your paper you were looking at MNIST to C-4, Celeb A to C-4. But I was curious, for example, if you took a color data set, let's say C-4, and then you went to some, let's say, black and white data set or a grayscale data set, whether that would affect the attack, or the number of classes that you're transferring to matters for the hijacking.
Thank you for yes. What you're saying is definitely on point. So first, the number of classes does matter, right? So far we only consider, or the main attack only consider a target or original dataset which has at least the number of the hijacking dataset, right? Or number of labels, right? So this is one limitation so far. And the second one, so MNIST is kind of a grayscale, and we can embed it in C4, but then you can do it like this. But then I totally get the point where basically, so we didn't really test their limits because we this was the first work we did, but then we definitely plan to see when will it fail, because I totally get that some tasks would be too complex to implement as a hijacking task. Okay.
And then a second question is, so the paper focuses mainly on the computer vision task, right? And I see that in the paper you talk about, this will probably work for other, domains. But one curiosity would be if you could do some sort of cross-domain hijacking, right? Maybe you have a text model, and then you use your attack, or I guess a modification of it, in order to take a vision task and then run it through a text model. I wonder if there are any thoughts towards that.
Yeah, so thank you for this question, because this is an ongoing. So this is something which we are currently trying, and we hopefully will be able to publish some results soon. But I will keep you definitely updated with this. But the short answer that you can still do this. Yes, you can use datasets from different domains to do this attack, and hopefully we will be able to publish something soon about this.
Okay, cool. I'll shoot you an email after then. Thanks.
Thank you.
Thanks for the great talk. I'm Philip from TU Darmstadt, and I would just want to know whether you observed that transfer learning actually has an impact on the effectiveness of your attacks. So basically, if I just start not from scratch when training the model, but use a pre-train model, and then, for example, just retrain the last layers, and only there your attack is applied.
Thank you for the question. So, in the paper, we try the two cases where basically we start from from VGG from scratch and a pre-trained VGG, and both of them can work. I think the pre-trained VGG converges faster, but then this is expected because it just doesn't start from from scratch. But we definitely tried the two setup, and it can still work at the two setup. But also, to be fair, so there is this feature extractor, and the feature extractor is pre-trained also. Right, so we didn't really search for a model which is pre-trained using a completely different and private data set. We didn't try this setting. But in the normal pre-trained model, I would say yes, it works against this normal pre-trained model.
Thank you.
Thank you.